this one and the one before this really are all done using software for the most part.
Okay, which I have the technology.
Okay.
Yeah.
Could you click on that technology so I could see what it says?
Yeah.
Do you have a T? So there's okay. So it's calculating the test statistics. That's the challenge here. I just need to know what formula to use. All right, you want to show me that one more problem?
Yeah, it's gonna be, I believe, this one.
Okay. All right. So got them all here. Do the easy ones first, which is the first and the last.
Mhm.
Right. All right, so let me share my screen and we'll get started here. So what you have to calculate is what's called the expected value matrix.
Uh-huh.
And so to do that, you need the row total and the column total of each.
Okay.
So we got like 126,
Uh-huh.
89, 18.
Mhm.
And we need the super total as well, which we add up. So please double check these. Any errors in this will
Yeah.
propagate to the problem here. 47, 10 is 132.
Uh, 7. Yeah, 132 and then 51, 42, 8.
33. And then you can check that that's right by adding up the column there.
Yeah, I got those. Yeah.
All right. So then to calculate the each entry here, like to
Mhm.
calculate this first entry, E11, you take the row total. So E11 is 126 times 132 divided by 233.
Okay.
And this is where it gets kind of messy because it
Mhm.
probably does not work out perfectly.
Yeah.
And then the rounding, and then there's lots of issues.
Mhm. So I got 71.38.
Right. So the question is, well, how many decimal places did you round to? I have no idea. Um, we had issues last time with this, so that's where I would probably like now that I've shown you how to do one, I probably would do this in like Excel to get some and like that way it's not rounding anything, which I know you don't have, but
Yeah, we don't use Excel.
right. So I'm concerned that if we use this value, it's gonna create a problem. If the test to stick four decimal places. So I know your goal is to get the right answer here. So I would like to do, I guess what
I
I
think.
said, which
Mhm.
like to find E12. E12 is 126 times 101 divided by 233,
Mhm.
and so on.
So should I just do it to the 4 decimal place because the
So
test statistic?
when you square, you actually need to go out to 8 and get it's double when you square numbers.
Okay.
And that's why this is such a problem. Like this is meant to be done in software, meaning like
Yeah.
not what we're doing here.
Mhm. Uh,
Um, so I'm gonna do it in another like once you get all the values, then I'll show you how to do the next part, if that's
okay.
okay.
Yeah.
So the chi-squared statistic is actually let me get all right, so equals this times this divided by this term. Right. I'm doing stuff in the other screen. You can't see it.
Oh, yeah.
I'm sorry. It's just gonna this is the only
Yeah.
way to do it correctly.
Yeah. So I think like at ASU they used to do business stats like with Excel sheets, but now they changed it because they added the technology. So now like the professors have changed how they taught or teach this class just by using the technology. But I wasn't really following the method he was teaching in class because it was like incorrect when you entered it in. So just was not helpful. So I was stumped.
It sounds like they need to get on the same page with
Yeah,
what they're doing.
yeah.
All right. So here, I think I've got them all. Just checking. Okay. So these are the values that I found
Mhm,
for those. And so the next thing is you take the chi-squared is the summation of the observed minus the expected squared over the expected.
mhm,
So for example, you would take 75 minus 71.38197, square it, and then divide it by 71.38197.
okay, I'll calculate
And
that.
then you do that for all of them, basically. So
Okay,
it really is tough to do. Observed equals the observed minus the expected squared divided by the expected. Okay, so here are those values. And you
mhm,
do all that. And then so the chi-squared is you add them all up.
mhm,
And this will be the first thing we can. So it's 0.9672. So
mhm.
that's that first box here.
Yeah.
Could you try that for us, please? No, I'm sorry. No. Oh my gosh, I'm so sorry. This is
Mhm,
not a chi-squared problem.
mhm.
I'm so sorry. Uh,
That's okay. I haven't entered anything. It's okay.
that last one. No, I'm sorry. None of these are chi-squared. Why did I think that? I'm so sorry.
No, it's
Everything
okay.
I just said is completely wrong.
It's okay.
And now we're gonna do it differently. Okay.
Okay.
So calculate the test statistic. The population distributions are known. That's good. So the test statistic Z is X bar one.
Which is
Okay.
75.
That's the sample size. Yeah,
47 minus 42. Yeah.
yeah, over the square root of 10 squared over 75 plus 8 squared over 51.
Yeah. So I recognize
All
this
right.
equation for sure.
Yeah, I'm sorry. I
No, it's
don't
okay.
know.
I'll type this into my calculator.
10 squared over 5 plus 8 squared over. All right, so 3.1079 is what I got.
Yeah, me too.
So the
So,
p-value, whether there's a significant difference. So that's a two-tailed test. So you go find the area to the left or right
mhm.
of one of them and then double it. I would find the area left of the negative 3.1079.
And this is a T table, correct?
No,
Or
because the
it's a
population distribution is known as Z,
it's a Z. Okay. So
normal distribution.
it's always Z. So to the left, I get the probability is 0.990, but the
You got
five
to do
is
you do the negative
the
one, or you got to do
negative.
one minus that. Yeah.
Okay, so negative is, yeah, wait, that's wrong. Negative
So if how many decibels for? So I get 0.0019.
0.19, yeah.
And then you're going to reject. You already got that, I guess. Reject
Mhm.
H0. There is a significant difference. All right. So sorry that took so long.
You know, it's
Hopefully the
okay.
next ones will go faster.
Yeah,
And then being okay.
yeah.
Now the issue with the next one, population's not known. So there's two there's yeah, the confidence interval here. So the issue is like I don't know which formula they're using for this,
Mhm.
which is there's two different T formulas. There's one that looks really like what we just did, S1 squared over N1 plus S2 squared over N2. And then there's another one that uses a pooled estimator.
Uh-huh. I
Have
think
you
it's the
seen?
first one.
Okay. So it's basically the same setup to
Okay,
find the value of the test statistic Z down here, and we'll
right.
get to the confidence interval.
Okay.
So your T is going to be 71 minus 76 over square root of 7 squared over 37 plus 8 squared over 42.
Mhm. Plus 8 squared.
I got minus 2.963. Would you mind checking that
Yeah,
for
I
us?
made a calculation or calculator error, so I gotta do the parentheses again. 6 divided by second. Do I put the denominator in a one whole parentheses or individually?
You don't need to because it's under the square root. It'll
Okay.
it'll look like slash square root, and then you can go 7 squared over 37 plus 8 squared over 42.
Got it. Uh, yeah, negative 2.9663. Yeah,
Will you test that? Because that will impact A and other stuff.
yeah. Let me plug that in. Negative 6. Let's see. Yeah, that's correct.
Great.
963. Yeah, okay, so that's
Right,
correct.
now the key value here, so the degrees of freedom, I don't know what you guys are using in here that will impact the calculation.
I have no clue how to calculate that. That's what I've been stumped on because I can't find the equation he uses.
Um,
And when I found
it's
it,
it's
Chegg, it's not right.
it is right or not right.
It's like not like right from what I've tried on my own. Because it was like N1
So
minus N2
yeah,
plus something.
it's typically N1 plus N2 minus 2.
Yeah, and that hasn't been working.
All right, let's try if you don't mind, but let's get to the easy stuff. Significantly different for the hypothesis test. So that is the one here. That's no, sorry, it's that one.
Yeah.
Yeah, you already maybe already got that down. So it's a two-tailed test, minus 2.963,
Mhm.
like that, 2.963. So assisting with some technology, degrees of freedom here is 37 plus 42 minus 2. What did I say?
Which is 77.
Yeah,
Right.
77. So let me grab my technology.
Mhm. So negative 2.
Degrees of freedom.
So it's 0.9959.
So you got to use the negative one and go left of it, and you're doubling it. So 0.0405.
0.
Regardless, it will be a reject. We can conclude.
Oh, okay, I see. Well, it says 5 decimal places, so wait, so I
0.0405.
wait, can I share my screen? Because I this is what I typed in. I
Sure,
don't know if this
sure.
is right. I just want to make sure
Yeah,
I'm
go.
doing technology
Yeah, go
that
for it.
is not
Yep.
a
So it's not a middle. It's
middle.
a,
It's just,
well, it's two-tailed. That'll do it.
oh, here it is.
One
Oh, I
zero
got it. That was my mistake. Okay,
one
got it.
zero zero 405.
Mhm.
So let me know if that's wrong, because
Mhm.
then we can adjust.
Yeah, I will put that in. That was wrong. 0 point. Yeah, I did not take that.
All right, let me try. So I've got access to some other technology that
Mhm.
might more closely align with this. Let me
Yeah,
enter the information there. See if we can figure this out.
yeah.
Sometimes they take the minimum degrees of freedom and subtract one. Uh, you can always look at the like view another example.
Mhm. Yeah, let me look. Practice another.
Sometimes that is useful to do.
Show answer.
That P stats to sample with summary
Yeah, I mean, I don't.
71, 7, 37 sample mean. 76. 8 and 42. Pool variance is off. All right, so compute. All right, so this one, the same freaking value. Yeah, we did it right. We don't understand.
It's not,
And,
yeah.
and that T is for sure 100% correct.
Yeah, the T is correct. It took the T. Yeah, it's just the P.
All
Zero
right.
point 0.00405. Yeah, I know.
So just I know I'm so the same. We're gonna have the same problem with the this up here if we're
Mhm,
using the wrong degrees of freedom.
mhm.
But here is the statistical output for that. How many decimal places are rounding to for that? 3.
3, yeah.
All right, so try minus 9.009 and minus 0.991.
Mhm. Yeah, I did not take the first one. These
Okay,
ones
so
are so tricky with the technology.
could you share your screen again? Can we see a like problem and does
Yeah,
it give the show solution or should yeah
yeah, it'll
after you go
show
to
the
the
stuff.
and then I
Mhm,
can see the formula for degrees of freedom, which
mhm.
will
Okay, I'll do deep, or here, I'll do practice another.
you may have to do the ones the radio boxes there to get the show solution also. Sometimes they um to say they don't have the show solution option.
It's just check score, hide answer, or
Here, I guess I can rerun it with this. Could you sorry, that's not what we want. Could you um sorry, trying to get could you just leave it, go up, scroll up a little more right there so I can
yeah.
compute this and then I can tell you what the issue is
Mhm,
if we can. 742 71 9 and 46 well 98% confidence interval. So I compute minus 9.05. Okay, so we're only off by the answer I gave you is only off in the thousands place.
okay, tens, thousands. Okay.
So it's probably the one. Yeah, they're both going in which direction? Five. This one says 5/8 though. So try 010 minus 0.99. Let's see, 942, 990. Okay. All right, so let me share my screen. Okay, so try minus 9.010
Mhm.
uh, minus 0.990.
Okay, let
And if
me.
those don't work, you can try 0.992 and minus 9.011 or
Okay.
0.08. It's within a thousandth. I don't know what to say.
Yeah. Mm, Yeah, it took the 0 point, or sorry, the negative 9.0, the second option, basically. Yeah.
And my guess is this one's off in the p-value. It's like 404 or 06.
Okay, I can try 404. Okay, we can just move on to the next one. It didn't take the 404. I have one more submission, but I'll come back to it.
All right, so this one is a pair t-test. Once you calculate the differences, it's just a regular t-test.
Uh-huh.
So the only one we'll be able to get
Okay.
done with the time remaining.
Okay.
84, 79.
Mhm.
So I'm entering the data and then I'll compute the differences and then
Are you using Excel to do this?
no, your calculate once you get the differences, you just put that into your calculator.
Oh.
I'm using something else, but
Mhm.
and so on. Um, 93. Oops. I know you want the answers. I mean, that's not really the best way to do this, but
No.
that's what we got. So I'm trying here to give you what you prepared.
Well, I want to learn how to do it as well because I just,
Well, that you probably have to schedule a full hour for that truth
yeah,
check
I'll
because
do that for like next
you
week for
can
sure.
do it. Yeah, what it's up to you.
Yeah.
So we're doing test statistic increased. Okay, so greater than compute. All right. So like I said, what the software does is it
Mhm.
computes the differences.
Mhm.
Let me snip that in. Uh, there's the differences,
I see.
and then the output here of the software tells us the other stuff that we want.
Mhm.
So that you have to calculate on this column here, you have to calculate the mean, the
Got it.
S, the N, and do the normal p-test
Okay.
on that. So now, here's the information we want. The p is minus 0.758.
The p-value?
No, the test
The t. Yeah.
statistic.
Yeah.
And p-value is always positive.
Mhm.
P-value is fairly large. Maybe I went the wrong direction on that. Maybe it meant the other direction.
Mhm.
So we're going to subtract it from 1, which gives you 0.2413. We do not reject. There is no significant difference.
Yeah. I'll try that. Yeah, it says the test statistic is wrong, or hold up. Because I put negative 0.758. Does that matter? Or
Shouldn't matter.
yeah, it didn't take that, which is weird.
Did it take the p-value?
Yeah, it took the p-value and the conclusion.
I mean, it's probably off by, it's probably off, it's minus 0.757 or 759. I mean, it
Okay.
can't be that far off to give you the same one.
I'll try that.
Or it's positive.
Mhm.
That could also be the issue. Which direction do they want you to do? Or after? Oh, it is positive. It's positive.
Mhm. So
That's
not
the issue.
okay. 0.98. Hold up. Let me get rid of that.
All right. We do unfortunately have to stop.